Hello everyone. In a previous class, we discussed about the testing of DC machine, direct testing as well as indirect testing of DC machine. Inside an indirect method of testing to find out the efficiency of the DC machine, we discussed about Swinburne test of the DC machine. In this lecture, we will study about regenerative or Hopkinson test. It is also known as back-to-back test. After this, we will move on. The next topic is retardation or running down test of the DC machine. The next is the application of DC machine in different areas. And finally, the reference of this presentation. So in this lecture, we will cover last 4 topic one by one. बिकॉज पहले वाले टॉपिक ऑलरेडी हम पिछले वाले लेक्चर में स्टडी कर चुके हैं, तो इसमें लास्ट के जो 4 टॉपिक हैं उनको हम वन बाय वन स्टडी करेंगे. पिछली वाली क्लास में हमने देखा था टेस्टिंग ऑफ डीसी मशीन का इंट्रोडक्शन, कि आखिर हम टेस्टिंग क्यों करते हैं, टेस्टिंग करने का मेन रीज़न क्या है. फिर हमने स्टडी किया था देयर इज 3 टाइप टेस्ट basically perform in DC machine: open circuit test, short circuit test and load test. टेस्टिंग का मेन पर्पस है टू फाइंड आउट द लॉसेस, और लॉसेस अगर हमें मिल गए तो हम इजीली एफिशिएंसी जो है मशीन की कैलकुलेट कर सकते हैं. आफ्टर दिस वी डिस्कस्ड अबाउट डायरेक्ट मेथड. डायरेक्ट मेथड में हमने स्टडी किया था पिछले वाले लेक्चर में कि जो मेथड है वो ज़्यादा एफिशिएंट नहीं है डायरेक्ट मेथड, क्योंकि इसके बहुत सारे इसमें हमने 2 मेथड यूज़ की थी. पहला ब्रेक टेस्ट, और ये कैलकुलेशन किया था हमने ब्रेक टेस्ट का पूरा. And second, the motor drives a calibrated generator, that is one whose efficiency is known at all the loads. So the output of the generator is measured with the help of an armature and voltmeter. तो ये 2 टेक्निक्स हमने डायरेक्ट मेथड में स्टडी की हुई हैं. कैलकुलेशन किया था हमने इनपुट आउटपुट एज वेल एज द एफिशिएंसी ऑफ डीसी मशीन का. नेक्स्ट टॉपिक जो हमने स्टडी किया था इनडायरेक्ट मेथड ऑफ टेस्टिंग टू फाइंड आउट द एफिशिएंसी ऑफ डीसी मशीन. इसमें हमने स्टडी किया था स्विनबर्न टेस्ट. ये हमने ऑलरेडी स्टडी कर लिया है कि ये टेस्ट होता क्या है, कैसे परफॉर्म करते हैं, सर्किट डायग्राम क्या है और किस मशीन के लिए एप्लीकेबल रहेगा. अब इस लेक्चर में हम फोकस करने वाले हैं रीजनरेटिव और हॉपकिंसन टेस्ट पे एंड रिटार्डेशन और रनिंग डाउन टेस्ट एंड द एप्लीकेशन ऑफ डीसी मशीन. सो ये स्विनबर्न टेस्ट ऑलरेडी हमने स्टडी कर लिया पिछले वाली. Now the next topic is regenerative or Hopkinson test of the DC machine. Hopkinson test is another useful method of testing the efficiency of a DC machine. It is a full load test and it requires two identical machines which are coupled to each other. What's the meaning of identical machine? मतलब दोनों जो मशीन हम यूज कर रहे हैं उनका रेटिंग जो है वो सेम होना चाहिए. One of these two machines is operated as a generator to supply the mechanical power to the motor and the other is operated as a motor to drive the generator. For this process of back-to-back driving the motor and the generator, Hopkinson test is also called as back-to-back test or regenerative test. तो इसमें हम जो मशीन है बैक टू बैक ड्राइव करते हैं या ऑपरेट करते हैं, सो दिस इज कॉल्ड द बैक टू बैक टेस्ट और इसको हम रीजनरेटिव टेस्ट भी बोलते हैं. If there are no losses in the machine, then no external power supply would have needed. But due to the drop in a generator output voltage, we need an extra voltage source to supply the proper input voltage to the motor. Hence, the power drawn from the external supply is therefore used to overcome the internal losses of the motor generator set. The Hopkinson test is also called a regenerative test or back-to-back test और हीट रन टेस्ट. इसको हम हीट रन टेस्ट भी बोलते हैं और इस टेस्ट के लिए हमें एक मोटर जनरेटर सेट की जरूरत होती है. So next is a connection diagram of Hopkinson test. This is the motor generator set, means motor is coupled with the generator, or we can say that the two identical machines. One is operated into generator as a generator and another is operated as a motor. Here is a circuit connection for the Hopkinson test shown in a figure below. Next slide में आप देखेंगे figure. A motor and a generator, both identical, are coupled together. When the machine is started, it is started as motor. The shunt field resistance of the machine is adjusted so that the motor can run at its rated speed. फील्ड सर्किट में हम एक रियोस्टेट लगाते हैं जिसको हम वेरी करके मोटर की स्पीड को कम ज़्यादा कर सकते हैं और रेटेड स्पीड तक हम मोटर को रन कराते हैं बाय यूजिंग द शंट फील्ड रेजिस्टेंस. द जनरेटर वोल्टेज इज नाउ मेड इक्वल टू द सप्लाई वोल्टेज बाय एडजस्टिंग द शंट फील्ड रेजिस्टेंस कनेक्टेड अक्रॉस द जनरेटर. So this is the circuit diagram for Hopkinson test. Two identical motor coupled with each other. Two identical machine, not motor. So one machine operated as a motor, another machine operated as a generator. This equality of these two voltages of generator and supply is indicated by the voltmeter as it gives a zero reading at this point connected across the switch. The machine can run at rated speed and at desired load by varying the field current of the motor and the generator. बहुत ही सिंपल सर्किट डायग्राम है. वोल्टमीटर को हम सर्किट के साथ पैरेलल में कनेक्ट करेंगे और अमीटर ऑलवेज कनेक्टेड सीरीज विद द सर्किट. Calculation of efficiency by Hopkinson test. अब टेस्ट से हम एफिशिएंसी को कैसे निकालेंगे? जब मशीन मोटर की तरह यूज होगी और जब जनरेटर की तरह वर्क करेगी. So let V is a supply voltage of the machines. Then the motor input is equal to V into I1 plus I2. सर्किट डायग्राम से हम देख सकते हैं where I1 is equal to the current from the generator, I2 the current from the external source, and the generator output is equal to V into I1, equation number 1. Let both the machines are operated at the same efficiency eta. Then the output of the motor is eta into input is equal to eta into V in bracket I1 plus I2, bracket close. Input to the generator is equal to output of the motor, because both machines are identical. So is equal to eta into V in bracket I1 plus I2, bracket closed. So output of the generator is equal to eta into input is equal to eta into bracket eta into V in bracket small bracket I1 plus I2, bracket close, is equal to eta square. V into I1 plus I2, this is equation number 2. From equation number 1 and 2 we get V into I1 is equal to eta square into V in bracket I1 plus I2, bracket closed, or I1 is equal to eta square in bracket I1 plus I2, bracket closed, or eta is equal to under root of I1 divided by I1 plus I2. Now in case of motor, armature copper losses in the motor is I square R. So we can write the equation in bracket I1 plus I2 minus of I4 whole square into RA. Where RA is the armature resistance of both motor and generator, and I4 is the shunt field current of the motor. Shunt field copper losses in the motor will be is equal to V into I4. Next, in case of the generator, armature copper losses in a generator is equal to in bracket I1 plus I3 whole square into RA. I3 is the shunt field current of the generator. The shunt field copper losses in the generator is equal to V into I3. Now, power drawn from the external supply is equal to V into I2. Therefore, the stray loss in both the machines will be W is equal to V into I2 minus of in bracket I1 plus I2 minus of I4 whole square into RA plus V into I4 plus in bracket I1 plus I3 whole square into RA plus V into I3. Let us assume that the stray loss will be same for both the machine, because both machine is identical. So the stray loss per machine is equal to W by 2. Next is the efficiency of generator. The total losses in the generator WG is equal to in bracket I1 plus I3 whole square into RA plus V into I3 plus W by 2. W by 2 because the machine are identical. So losses is half. The generator output is equal to V into I1. Then the efficiency of the generator eta G is equal to output power divided by input power, or we can say that output power divided by output power plus losses in mathematical form is equal to V into I1 divided by V into I1 plus WG. So by using this formula, we can calculate the efficiency of the generator. Next is the efficiency of motor. The total loss in the motor is Wm is equal to in bracket I1 plus I2 minus of I4 whole square into Ra plus V into I4 plus W by 2. The motor input, we know that, is equal to V into bracket I1 plus I2. Then the efficiency of the motor is eta M is equal to output power divided by input power, or we can say that input power minus losses divided by input power. In mathematical form, V in bracket I1 plus I2 bracket close minus of Wm divided by V in bracket I1 plus I2. By using this formula, we can calculate the efficiency of the motor used in this test. The advantages of Hopkinson test is this test requires very small power compared to full load power of the motor generator coupled system. That is why it is economical. Large machines can be tested at rated load without much power consumption. The next advantage is the temperature rise and commutation can be observed and maintained in the limit because this test is done under full load condition. Change in iron losses due to flux distortion can be taken into account due to the advantage of its full load condition. Next one is efficiency at different load can be determined. By using this test, we can calculate the efficiency at different load conditions. So these are the advantages or merits of Hopkinson test. Next one is a disadvantages or drawback of Hopkinson test. The demerits of this test are: it is difficult to find two identical machines needed for Hopkinson test. थोड़ा सा कॉम्प्लिकेटेड होता है दो एग्जैक्ट आइडेंटिकल मशीन को फाइंड आउट करना और ढूंढना. Number 2, both machines cannot be loaded equally at all the time. It is not possible to get separate iron losses for the two machines, though they are different because of their excitations. Number next, it is difficult to operate the machines at rated speed because the field currents vary widely. So, these are the demerits of Hopkinson test. The next topic is retardation or running down test of DC machine. This is the best and simplest method to find out the efficiency of a constant speed DC machine. Example, shunt generator and motor. ये वाला टेस्ट हम किसके लिए करते हैं परफॉर्म? अ कांस्टेंट स्पीड डीसी मशीन्स के लिए परफॉर्म किया जाता है. इन दिस मेथड वी फाइंड द मैकेनिकल फ्रिक्शन और विंडेज एंड आयरन लॉसेस ऑफ द मशीन. देन knowing the armature and shunt copper losses at any load condition, the efficiency of the machine can be calculated at that load. मतलब हम डिफरेंट लोड पर एफिशिएंसी कैलकुलेट कर सकते हैं बाय यूजिंग रिटार्डेशन और रनिंग डाउन टेस्ट के थ्रू. The principle of this test is: consider a DC shunt motor running at no load. Number 1. If the supply to the armature is cut off but the field remain normally excited, the motor slows down visually and finally stops. The kinetic energy of the armature is used up to overcome friction, windage and iron losses. Number 2. If the supply to the armature as well as field excitation is cut off, the motor again slows down and finally stops. Now, the kinetic energy of the armature is used up to overcome only the friction and windage losses. This is expected because in the absence of flux, there will be no iron losses. By carrying out the first test, we can find out the friction, windage and iron losses and hence the efficiency of the machine. However, if we perform the second test also, we can separate friction and windage losses from the iron losses. Theory of retardation test. In the retardation test, the DC machine is run as a motor at a speed just above the normal. Then the supply to the armature is cut off while the field is normally excited. The speed is allowed to fall to some value just below normal. The time taken for this fall of speed is noted. From these observations, the rotational losses, that is friction, windage and iron losses, and hence the efficiency of the machine can be determined. क्या करते हैं हम इस टेस्ट में? मशीन को नॉर्मली जो नॉर्मल स्पीड है उससे थोड़ा ऊपर हम मशीन को रन कराते हैं और आर्मेचर का सप्लाई कट ऑफ कर देते हैं, फील्ड को नॉर्मली एक्साइटेड रहने देते हैं। इस कंडीशन में क्या होता है, स्पीड धीरे धीरे कम होती है। इसी को हम रिटार्डेशन प्रोसेस बोलते हैं। तो इस प्रोसेस के थ्रू हम फाइंड आउट कर सकते हैं फ्रिक्शन, विंडेज एंड आयरन लॉसेस और उसी के थ्रू हम एफिशिएंसी ऑफ द मशीन कैलकुलेट करते हैं। Let n is equal to normal speed in rpm and omega is equal to normal angular velocity and radian per second is equal to 2 pi n by 60. We all know that. So the rotational losses W is equal to rate of loss of kinetic energy of armature, or we can say that W is equal to d by dt in bracket 1 by 2 I into omega square is equal to I into omega d omega by dt. Here I is the moment of inertia of the armature as omega is equal to 2 pi n by 60. So W is equal to I into 2 pi n by 60 into d by dt in bracket 2 pi n by 60 bracket closed is equal to 2 pi by 60 whole square in dn by dt. Or W is equal to 0.011 I into n dn divided by dt. Let us illustrate the application of retardation test with a numerical example. Suppose the normal speed of the DC machine is 1000 rpm. When the retardation test is performed, the time taken for the speed to fall from 1030 rpm to 970 or 970 rpm is 15 seconds with the field normally excited. If the moment of inertia of the armature is 75 kg meter. Then the rotational losses W is equal to 0.011 In dN by dt. Here I is equal to 75 kg meter square, N is equal to 1000 rpm. हमें अभी न्यूमेरिकल में गिवन है जो हमने एग्जांपल लिया हुआ है. So dN is equal to 1030 minus of 970 is equal to 60 rpm and dt is equal to 15 seconds. So W is equal to 0.011 into, put the value of I and N, so 75 into 1000 into 60 by 50. So we get 3300 watts. The main difficulty with this method is the accurate determination of the speed which is continuously changing. तो एक्यूरेट स्पीड इसमें निकालना थोड़ा सा मुश्किल होता है क्योंकि स्पीड हमेशा हमारी जो होती है वो चेंज होती रहती है. यही इसकी मेन डिफिकल्टीज है इस मेथड की, और इस मेथड से हम फाइंड आउट कर सकते हैं लॉसेस इजीली. So the next topic is applications of DC machines. In the present day world, the electrical energy is generated in bulk in the form of an alternating current. Hence, the use of DC machines, that is DC generators and motors, are very limited. They are mainly used in supplying excitation of small and medium range alternators. Alternators means synchronous generator. The industrial application of DC are in electrolytic process, welding processes, and variable speed motor drives. The main application of three types of DC motors are given below. Three types means DC series, DC shunt, and DC compound motor. So first one is DC series motors. The series DC motors are used where the high starting torque is required. ये बहुत ही इंपॉर्टेंट है, जहां भी हमें हाई स्टार्टिंग टॉर्क चाहिए है वहां हम DC सीरीज मोटर का यूज करते हैं. एंड वेरिएशन इन स्पीड आर पॉसिबल. फॉर एग्जांपल द DC सीरीज मोटर आर यूज्ड इन ट्रक्शन सिस्टम. सबसे इंपॉर्टेंट जो यूज है DC सीरीज मोटर का वो है ट्रक्शन सिस्टम, मीन्स रेलवे में. रेलवे जो है हमारा इंडियन रेलवे, उसमें DC सीरीज मोटर का यूज हम करते हैं. नेक्स्ट है ट्रेन्स, एयर कंप्रेसर्स, वैक्यूम क्लीनर, स्विंग्स मशीन्स एक्सेट्रा. तो ये जो है ये DC सीरीज मोटर के एप्लीकेशन है. और DC सीरीज मोटर का यूज हम कहाँ करेंगे? जहां हमें हाई स्टार्टिंग टॉर्क की रिक्वायरमेंट होगी. नेक्स्ट इज अ DC shunt motor. The shunt motors are used where the constant speed is required and starting condition are not served. तो शंट मोटर का यूज हमें कहाँ करना है? जहां हमें कांस्टेंट स्पीड की जरूरत है. The various application of DC shunt motor are in lathe machine, centrifugal pumps, fans, blowers, conveyors, lift, weaving machines, and spinning machines, etc. So these are some example where the DC shunt motor is used. Next is a DC compound motors. The compound motors are used where high starting torque and fairly constant speed is required, because the compound machine is a combination of series and shunt motor. तो इसलिए जब हमें स्टार्टिंग टॉर्क भी हाई चाहिए और फेयरली कांस्टेंट स्पीड चाहिए तो उस जगह पे हम कंपाउंड मोटर्स का यूज करते हैं. द एग्जांपल ऑफ यूजेस ऑफ कंपाउंड मोटर्स आर इन प्रेस, sheds, conveyors, elevators, rolling mills, heavy planers, etc. So these are the place where the compound motor are used. The small DC machines, whose ratings are in fractional flow watt, are mainly used as control device such in tacho generators for the speed sensing and in servo motor for the positioning and tracking. The small DC मोटर का हम यूज़ करते हैं एज अ टैको जनरेटर की तरह, एज अ सर्वो मोटर की तरह. सर्वो मोटर में पोजिशनिंग अगर मुझे फाइंड आउट करना है या ट्रैकिंग, तो हम स्मॉल DC मशीन का यूज़ वहाँ पे करते हैं. Next one is the application of various type of DC generators are as follow. Separately excited DC generators. The separately excited DC generators are used in laboratories for testing as they have a wide range of voltage output. Second, used as a supply source of DC motors. Next one is a shunt bound generators. DC shunt bound generators are used for lightning purpose. Second, used to charge the battery. Third one, providing excitation to the alternators. Next one is series bound generator. DC series bound generators are used in DC locomotives for regenerative braking. लोकोमोटिव्स मतलब जो ट्रेन का इंजन होता है उसको हम लोकोमोटिव्स बोलते हैं, और रीजनरेटिव ब्रेकिंग के लिए हम सीरीज बाउंड जनरेटर का यूज करते हैं फॉर प्रोवाइडिंग द फील्ड एक्साइटेशन करंट. Number next, series bound generators used as a booster in distribution networks. It is also used in over compound cumulative generators, are used in lightning and heavy power supply. The flat compounded generators are used in offices, hotels, homes, school, etc. Differentially compound generators are mainly used for arc welding purpose. So these are some application of DC motor as well as the DC generators. The next topic is the references. So these are the references of this presentation. And any doubt, anybody, so please ask me, and thanks for watching this video.